Hey everybody, and welcome to the first video of Chapter 4. Now in this chapter, we're going to be talking about the determinants of interest rates and how they move. And to introduce the topic, we're going to talk about two topics. First is what determines how investors construct their portfolios, and then we're going to talk about the specific topic of portfolio diversification. So there are five main determinants of portfolio choice, and we're going to talk about all five in this video. First is investor wealth. Second is the expected rate of return from an investment. Third is the degree of risk in an investment. Fourth is the liquidity that an investment provides the investors. Fifth is the cost of acquiring information about making a potential investment. So, if you remember back from chapter 2, your wealth is defined as your total assets minus your total liabilities. And there's two stylistic facts about wealth that economists use. First is that it generally increases over time for investors. So, for example, us as college students, we don't have as much accumulated wealth now as what we're going to have 20 years down the road once we graduate, get a stable job, etc. The second stylized fact is that as you increase your wealth, the number of investment options increases. And that's partially because of gatekeepers in the financial market, such as hedge funds requiring certain wealth minimums and investment minimums. And it also means that as you increase your wealth, you can spend on more information to make more complicated or obscure investment decisions. So the second determinant is super important. So it's really important you guys understand this really well. And that's the expected rate of return that an investment provides. So all else held equal, an investor's objective is to maximize their future return. But they can't see into the future. They are not clairvoyant. And so an investor, when deciding whether or not to make an investment, tries to calculate the expected rate of return that that investment will provide. And so, all else held equal, this is what they're trying to maximize. And we calculate the expected rate of return using equation 1. And in it, let's say that there's two different events occurring, one that increases in investment by 4% and one by 8%. Well, the expected return is the probability of the first event occurring times the value or return that that event provides, plus the probability of event number 2 occurring times the value that event 2 provides. So using this example, if there's a 50% chance of each, we'll say that the expected return is equal to 0.5 times 4% plus 0.5 times 8%. And sorry, that was pretty bad, so we'll redo that. 8%. So the expected return is equal to 6%. And in equation 2, we say the exact same thing, just in this more generic notation that I'm trying to get you guys used to. It just says that the expected return is equal to the sum of all possible probabilities of an event occurring times the associated value of them occurring. So using the example above, the expected return can just be extended out to equal P1 V1 plus P2 V2. But one of the benefits from the second notation, apart from the fact that it took me, like a tenth of the space to write it, is that it's generic enough that if there were 10 different events, we can still calculate the expected return and write it using the same formula. So that's why it's so nice to use this kind of notation. Now, the third determinant of portfolio choice is also very important, and that is risk. And I'm sure that you guys have heard risk referenced to before, but it is just the degree of uncertainty in the return of an asset. So, all else held equal, investors are usually going to be risk adverse. They want to minimize their exposure to a certain amount of risk. And when comparing two assets with the same expected return, they're going to choose the one that has the least amount of risk. And we calculate risk by using volatility derived from the standard deviation of an asset's actual returns over the years. So let's just say in year 1, the asset had a return of 4%. And in year 2, the asset had a return of 8%. Well, we can calculate the standard deviation using equation 3, which you should recognize from your intro to statistics courses, to get the standard deviation of this asset historically. So if we calculate it, our bar is going to be 6%. And so on the top, we're going to get the sum of 4 minus 6, so -2, squared, so 4, plus 8 minus 6, so 2, squared, which is 4, over 2. So we're going to get 8 over 2, which is 4, square root of that is 2. We have a standard deviation of 2 in that case. If that confused you how I got that number, talk to me because it's really important you understand this formula. But because of this, if we want to compare it to a different asset, we're always going to take the one which has the lower calculated standard deviation. Next, number 4 is liquidity, which is the ease an asset can be exchanged for money if you remember back from chapter 1. And all else held equal, so if we're talking about same risk, same expected return, same upfront costs, investors are always going to choose a more liquid asset to invest in. And that's just because investors want access to money if they need it. So, that may be to pay off some other investment or they want to invest in something else. They want to be able to shed that asset as quickly as possible. And finally, the fifth one is the cost of acquiring information. So, to figure out all the first four, investors need to acquire information about the investments that they're looking at. And that information is almost never going to be costless. Because of that, investors are just always going to choose an investment that is not as costly to acquire information about. And the baseline for cost is always going to be US Treasury bonds. All the information with them is publicly available, easy to get, easy to understand, and every bond after that is more complicated to figure out and understand all of these first four. So when in doubt, investors are always going to choose the costless source of information. Now we're going to move on to the topic of diversification. And I purposely glanced over this in the first chapter so that we can talk about it more in depth here. Diversification is just the division of wealth among many different assets to reduce risk. And it reduces that risk by reducing a portfolio standard deviation. And I'm going to get into how that works and the mathematical dynamics behind that in a second. But we're going to first talk about how there are two actual different kinds of risk. The first one is market risk, and that's just the risk that is common to all assets of a certain type. So, for example, all airline companies were exposed to the same market risk when the pandemic broke out. It doesn't matter who it was, they were all, affected by the lockdown. However, idiosyncratic risk is risk that pertains to a particular asset specifically that is not shared with other assets. So, for example, at the beginning of the pandemic, Delta Airlines had way more debt than Southwest Airlines. And so, because of that, it was a lot more vulnerable to going bankrupt than Southwest Airlines. That is idiosyncratic risk because Southwest's financials are not going to be affected by Delta's debt. So idiosyncratic risk, includes anything from new projects that a company may be taking on to a restructuring to the decision making to, who even is running the company, who is the CEO, who are the shareholders, etc. So those all get classified under idiosyncratic risk. But now we're going to shift back to the topic of diversification and show just how cool this is about how diversification works. So we're going to use this very simple example. Asset 1 and Asset 2 have zero market risk that they share. So they're in completely different sectors of the market and they move independently from each other. But we're going to say that there's only two scenarios for each asset. There's a 50% chance that they go down by 5%, and there's a 50% chance that they go up 5%. We can calculate the expected return from a portfolio that contains only each one and then that contains both. So if it has individually the expected return is going to be 0.5 times -5 plus 0.5 times 5, which is equal to 0 for both assets. And the standard deviation is going to be equal to 5 minus 0 squared, so 25, plus -5 minus 0 squared, so 25. So it's going to be equal to the square root of 50 over 2, because there's two different possible returns. So that's individually. This is really important, this number right here. Now let's look at a combined portfolio where we put 50% in each. The expected return. Well, first let's actually back up. That would mean that there's four different scenarios. There's a 25% chance that they both go down. There's a 25% chance that asset 1 goes down and asset 2 goes up. There's a 25% chance that asset 1 goes up and asset 2 goes down. And there's a 25% chance that they both go up. So what is the expected return of this portfolio? Well, the expected return is still going to be 0. That's unchanged, right? And you can see that just by taking this formula where you set capital N equal to 4. But what's the standard deviation? Well, we now have 4 observations. We know that the mean expected return is still going to be 0. And so on the top, we're going to have 25 minus 0 squared. Or sorry, 5 minus 0 squared, which is 25 plus 0 plus 0 plus 25. And we're going to put that over 4 because now we have 4 observations. Well, this reduces down to 50 over, or sorry, that would have been right, but that's also unnecessary. 50 over 4, which is lower or smaller than 50 over 2. We're always going to take this standard deviation over the first standard deviation because it's lower, unless we're risk seeking. And so because of that, even though the expected return is the exact same by having a portfolio with only one asset or the other, by making the portfolio have 50% of each, we're actually going to make it a safer investment. So pretty cool. And that's going to be the end of chapter 1. If all of this math confused you, because I know that there is more in this video than in the previous ones, please reach out to me so that you understand for the rest of the videos what is going on. Otherwise, you can now move on to chapter or the second video.